So this is lesson for day 108, reasoning and proof. So now we're going into proofs in math. So in geometry, or any kind of math, you want to have logic. I talked to you about two types of logic yesterday. There was inductive reasoning and deductive reasoning. Inductive was when we had a rule, or a law, like the law of gravity. So remember yesterday, if I throw a ball up in the air, it's going to come back down. Why? Gravity. The law of gravity. Okay, there's logic. You were able to predict it's going to come back down, even though I threw it up in the air. It's going to come back down because of the law of gravity. Good. Okay, and then there's deductive reasoning. So that's when we start with a statement, and we have a second statement, and then we could predict what the third statement is, okay? So I'm going to give you two statements. Predict what the third one is. Ready? All students are awesome.
Yeah, students are awesome. True statement.
Okay, just listen. All students are awesome. All the kids in San Dimas are students. Therefore what?
All kids in San Dimas are awesome.
That's right. You got it? Okay. So that's a syllogism. And that was a little rough, but we could make a couple statements and connect them together. Or we could even do that in math, right? Let's say that A is equal to B. Let's see if you could get this. A is equal to B. Here's your first statement. So B is equal to C. What can you tell me? If A is equal to B and B is equal to C, what can you tell me? What's something you can predict? Hey, look at that. A is equal to C. Would you all agree with that?
Yes.
Okay, good. Or here's another one. Ready? 3 is equal to 5 minus 2. That's the first statement. 5 minus 2 is equal to 12 divided by 4. Start with here. What? So 3 is equal to what? Do y'all see that? It's a little confusing, right? But does that logically make sense? Yeah. Okay. So this is called a syllogism. It's an old Greek thing, but we use this logic, okay? And that's called deductive reasoning. What kind of reasoning is the 3-step one? Deductive. And then when we use laws and rules to prove things that we know, what's that kind of reasoning called? Inductive reasoning. Okay. You good? Okay. Okay, so we wrote some of these down yesterday, postulates. So in math we have rules. We're going to talk about some rules today. There are statements you could accept as true. You don't have to write this down, okay? We wrote this down yesterday, okay? Postulates. So a postulate or a law in real life is like the law of gravity. Then we have theorems, or just things that they're statements we can prove using a series of logical steps. So there's certain things we can't just assume that are true, but someone proved them. And we call them theorems. What's one theorem you all know that we talked about like a week ago? Yes?
The Pythagorean theorem.
The Pythagorean theorem, that's correct. What's the Pythagorean theorem, everyone?
A squared plus B squared equals C squared.
Okay, cool. So, how did they figure this out? Did they just, one day, they're like, hey, you were born and your mom's like, A squared plus B squared equals C squared. Is that what happened?
Yes.
Or did you already know that in your brain when you were born?
No.
No, you learned it in school. So how do you think someone figured it out? They had to prove it, right? Someone proved it once upon a time. What was the guy's name?
Well, I don't know.
Bob. His name was Bob. No, it was blank. It wasn't me. It was Pythagoras. Okay, Pythagoras, he proved it. He went through a series of steps and he's like, hey, this works every time. And then everyone's like, cool, we don't have to follow all the steps just to prove it. We could assume it's true and we'll call your equation called the Pythagorean theorem. Okay? And then now all you kids have another lesson you have to do in your life because of Pythagoras. So say, thanks, Pythagoras. Okay, thanks. Okay, you good? Okay, cool. The next one is a counterexample. All birds can fly.
No.
Penguins can't fly.
Okay, can penguins fly? No, they can't. So, do y'all see that counterexample? Do y'all see that counterexample? Penguins can't fly. That's our counterexample. Therefore, all birds can't fly. We just made it false. Okay, that was my conjecture. Supplementary angles. Raise your hand if you've heard of the word supplementary before.
Yes.
Okay, cool. So what I'd like you to do, these are 3 new ones I want you to write down in your notes. Supplementary angle. We already got counterexample, complementary angle, and linear pair. Please write these 3 down. Okay, no talking. I want you to I'd like you to write these down into your notes. Supplementary angles is when we have 2 angles. Well, let's start with complementary. Complementary is a little bit easier to start with. Let's say I had 2 angles here. This is an angle. Let's call this angle A, B, and C. Is this a 90-degree angle yet?
Yes. No. I don't know.
We don't know. What if I put this little box here? Can we assume there's a 90-degree angle now?
No. Yes.
Yeah, when you see the little box in the corner, how many degrees is that angle? Okay, cool. I just want to make sure y'all know that. Okay? You good with that? So, let's say I put a new line right here. Well, actually, let's put a new point in the middle. Let's call this point X, okay? And how many angles do you see up here now? Two of them, and then don't you see a third one, the big one, right? Y'all see that? How big is angle ABC? Okay, cool. So, do you all agree that this is angle ABX? And do you all agree that this is angle XBC? Do you all see that?
Yeah.
Okay. Would you all agree that if this whole thing is 90, if you take angle ABX and you add angle XBC, how many degrees is it altogether?
90.
90 degrees, right? These angle ABX and angle XBC are complementary, meaning they add up to how many degrees? 90. Does that make sense? Complementary angles. Okay, tell your group what complementary angles are. Ready, set, go. 7 seconds.
2 angles that add up to 90 degrees.
Yes.
Go, Carly, go.
Okay, cool. Ready? Next one are supplementary angles. Ready? Just a little background knowledge. Ready? 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 I'm going to draw a circle out here. Okay? How many degrees all the way around the circle? How many degrees is it? How many degrees? Good, 360. You all agree with that? Okay. Let's say I take a line and I need you all to listen. Let's say I take a line down the middle of the circle. Perfectly down the middle. How many degrees is it from one side of the line to the other right here, to stop? How many degrees is that? How many degrees, everyone?
100.
Good. And how many degrees, if you were to complete all the way around, how many more degrees?
180.
Okay, cool. So we got 180 and 180, right?
Yes.
So I got a question for you. If I took this line, or if I took the circle and just erased the circle and just had a line, how many degrees is it from one side of the line to the other still? Do you all agree with that? So all lines are, how many degrees are the angles or lines? You all follow me right now? Okay, look up here. So here we go. I'm going to draw a new line down here. Let's call this line X, Y, and Z. Okay? So we'll call this line
X, Y, Z.
XZ or XY, or I'll call it XZ, okay? How many degrees is this angle XYZ?
180.
Good, 180. Okay, ready? I'm going to put a new point there. Let's put a new point in the middle. Let's call it point P, okay? And let's just make a line that goes from it, okay? How many angles do you see up here right now?
2. 3.
What are the 3? What's the first one?
straight line.
X, Y, Z. That's the first one I showed you, right? What's the second one? X, Y, P. Actually, it's angle X, Y, P, right? What's the third one? Angle P, Y, Z. How many angles?
3.
3. So would you agree that angle X, Y, Z is 180?
Yes.
Yeah. So wouldn't you agree that angle XYP plus X or PYZ is going to be equal to 180 degrees?
Yeah.
Does that all make sense, everyone? Okay, cool. So this is called, these two angles are called supplementary angles because when you add them together, they equal how many degrees?
180.
Okay, good. 2, 7 seconds. Talk to your group. How do you know, what are supplementary angles? Okay? Okay. You good with that? Y'all like that? I hope so. Okay, cool. So, I'm going to back this up just a smidget, okay? Eyes on the screen. Let's say I take away this line again, the P, okay? This is the line, right? Would y'all agree with this? How many degrees is this angle XYZ again? 180, okay? Eyes up here. When I put in an angle in there, or a ray, when I put this ray in here, YP, ray YP, these two angles are also called a linear pair, meaning they share the same line. What does pair mean?
Share the same line.
A linear pair means to share the same line, and it's when they share the same line, we could assume it's 180 degrees for both angles. Does that make sense?
Yeah.
So linear pairs are two angles that share the same line. Okay? Priest, tell your neighbors what a linear pair is.
A pair of adjacent angles whose non-common sides are opposite. You could assume that they are
Oh, I heard that. What did you just say, Eli? You could assume what?
180
Why can you assume they're 180?
because
They share the same line, right? Yeah, it's straight. So linear pairs are always how many degrees?
180.
Okay, good. Which means they're what kind of angles? Okay, y'all making that connection?
yes.
Okay, cool. Hey, and I'm sorry, this is really boring because there's a lot of definitions. You need to memorize the definitions because we have to apply the definitions. And I'll show you in a minute how hard that could get, okay? Alright. Anyways, that's that. Here we go, moving on. Okay, so these are some rules and postulates. I'd like you to write these down, okay? So I'll go through this as you write them down, okay? So everyone's trying to write these down in their notes, even someone on the video. You don't pause the, please don't pause the video here. You're going to listen as you write, okay? Here we go. Everyone's writing while I'm talking. And let me tell you why. You need to memorize all of the rules because we're going to go and do proofs in geometry. When we're doing geometry, listen up. Okay, so you do need to memorize these because we'll have to apply them later. If you don't memorize them, it'll be hard. Okay? So here we go. Through any 2 points, there's exactly one line. Okay? So, everyone's writing this down. Charles, you too, buddy. You can't just stare. Take your hats and hoods off too, please, kids. Thank you. Hats and hoods off. All the way off. All the way. Thank you. So, 2 points. So, you see this last light bulb on my Christmas light strand right here?
Yeah.
And you see that last light bulb? Would you all agree? Can we all make one imaginary line across, connecting the two of them?
Yes.
Yeah.
A perfect straight line? How many straight lines connect the two of these light bulbs?
One.
Only one. That's the rule, right? What's the shortest distance between 2 points, everyone? If you were like trying to get from one point of the quad to the next straight, what would you do to get from my class to, let's say, Mrs. Cocalis's class? If you wanted to take the shortest distance, what would you do?
Go straight.
Straight there. Does that make sense? A straight line. Okay. Cool. That's the definition here. Next one. Through any three non-collinear points, there is exactly one plane containing them. So remember, a plane is a flat surface that has no depth, and it goes on forever in each direction. Okay. Dylan and Matt, I don't think you guys are writing. You're just watching me. I need you guys to write, okay? Everyone's writing, okay? I need you all to write. Okay, well then come sit by Tommy. Okay, so if I have 3 points, they share a plane. Okay, so just like on this picture, we could see that there is a plane here. There's 3 points on the plane. Once I have 3 points, I have a plane. Okay? So even if I were to make 3 points in 3D, let's all eyes on me for 5 seconds. Ready? Let's have a point here, and a point here. I can make a plane connecting the 3 points. Okay? I need 3 points to create a plane. Can you all imagine that? Okay, good. So write that down. Next, if 2 points lie in a plane, then the line containing those points lie in the plane. Okay? If 2 points lie in a plane, then the line containing those points lie in the plane. So let's think about a line. You see this line right here? Can you all see these 2 points right here on the line? You all see these 2 points right here?
Yeah.
Cool. If I took a point that was exactly in the middle of these 2 points and say right here, can we all imagine a point right here in the middle of these 2 points? Can you all imagine that? Yeah? And can we all imagine a point between these 2 points right here? Like right here? Can you all imagine that? And can you all imagine that I could get a new point in between these 2 points like right here? And couldn't I keep going and do this forever, right? And take a point between 2 points and another point between 2 points? How many points are on a line? Then.
Two.
No, how many points are on this line then? Can we imagine? No, not 3. How many? Infinite, right? There's an infinite amount of points. We could create an infinite amount of points. Okay? So what this is saying is, if I have this line with an infinite amount of points and I put it on a plane, all of those points, all those infinite points are on that plane. Okay? Next one, if 2 lines intersect, they intersect in exactly 1 point. So just want to set something clear. Do lines curve at all? Yes or no? No, they don't. They do not curve. Lines do not curve. Parabolas or quadratic equations curve, but lines do not curve. Okay? Lines are always straight. So, let's pretend each of my arms were a line. Okay? Eyes up here. Let's say I had a line up here and a line underneath it. Are my lines crossing right now?
No.
No, they're not. So, are there any points that they meet?
No.
No. Okay, let's say they do cross. Let's say I put them together. How many times do these straight lines cross?
Once.
Once. Do these lines curve?
No.
No, they can't. So will they ever cross back at each other again?
No.
No, they won't. They only cross once, okay? Basic assumption here we need to make. Alright, the next thing are the properties of equality right here. We're not going to write these down, but don't they look familiar? Do you remember these?
Yeah.
What's the addition property of equality? What does that mean when we do that? What's that? When you add what? Tell me any words. When you add what? You're there. You add the same thing to both sides. Okay, what's the addition property of equality? Add the same thing to both sides. What about subtraction property of equality? What's that? Good. What about multiplication property of equality? Good. What about division property of equality? Okay, good. These are some new ones. You don't need to write these down. These are in your book in section 16-4, so in your textbook. So I'm not going to make you write them in class because I don't want to take time doing this. Okay, 16-4. Oh, that's ugly. Let me write that a little nicer. Okay. Chapter 16, section 4. Okay. Reflexive property. The reflexive property is when we have the same thing equal to itself. It's kind of a weird property. But let's say we had Eli. Okay? Ranch Eli. So, okay? Let's say we could imagine 2 Elis. Let's say there are 2 Elis in here, exactly the same. Would Eli be equal to himself?
Yes.
That's the reflexive property, when you have the same thing equal to itself. It's kind of like one of those, like, oh, God. Okay? So anything is equal to itself. That's the reflexive property. You all agree with that? Okay, good. Is 1 equal to 1?
Yes.
Is 20 equal to 20?
Yes.
That's the reflexive property. Okay? Next is the symmetric property. Okay? Let me show you an example of a symmetric property. Let's say I had a can of Coke, okay? And let's say it was equal to $1. Can you all imagine a can of Coke equal to $1? Yes? Okay, eyes up here. Can of Coke equal to $1. Ready? Watch me do symmetric property. $1 equals a what? Good. Did it change my equation at all? Maybe the way it looks, but isn't it the same thing, right? That's called the symmetric property, okay? We're just flipping it. Symmetric property. Okay? You've all done this before. All right, next one is transitive property, okay? We did this earlier. Sorry this lesson is so long. Okay, A is equal to B. Here's the first statement. A is equal to B. Therefore, B is equal to C. So what's the last statement? What can we assume? What logic? Okay, what's that, everyone? A is equal to C. Okay, good. Okay, so I want to hear some talking because you kids are starting to fall asleep. Let's have Forrest tell the rest of the group what a reflexive property is. One's tell the rest of the group what symmetric property is, and then two's tell the group what transitive property is, okay? I'll give you about 30 seconds. Ready, set, go. I want to hear some talking. Here's some interaction.
It's something that, like 1 plus 1 is equal to the same thing as 2. Your turn, Carly. Symmetric property. Right there. You have to explain it. Mine was, it's equal to itself. It's the same thing. It's a club. You like it? No.
Last one, substitution property. That's when we switch something for another. So let's say you had your hamburger, and in and out, it comes with a spread. What can you substitute the spread for? Ketchup, right? Does that make sense? Right? Okay, good. Let's keep going here. Okay, there are three postulates. I need you to write these down. Not all of it. I need you to write the title. Postulate 1, segment addition postulate. Postulate 2, angle addition postulate, and then the linear pair theorem. That's all we have to write here. These are in your textbook, but I need you to write just the titles down because you need to memorize the names of them and what they mean. Okay, so segment addition postulate. Let's all look up here. This is super easy. You just have to think conceptually. Would you all agree that this is segment AC?
Yes.
You all see that? You see this point in the middle? AB? Would you agree that this segment AB plus this segment BC is equal to this whole thing? Do you all see that? That's segment addition postulate. Okay? Let's see who spoke last. Let's have the Forrest talk now. Forrest, really quick, 7 seconds. What's the segment addition postulate? Ready, set, go. Segment addition postulate. What does this mean? Talk to your group. Okay, so I heard some people struggling. It's when we take pieces of the segment and we add them together. So like we have AB. Let's say we take AB and then we add BC to it. Wouldn't you agree we have AC now? The total. Does that make sense? Y'all hear that? Let's say the first one, AB was equal to 5 centimeters, and then BC was equal to 3 centimeters. How long is AC then?
As long as AB means BC.
Which is what? Remember, AB was 5 centimeters, BC was 3 centimeters. How long is AC? 8. Okay. Okay, does that make sense, everyone? I heard that. I like it when I hear ah, because that means you got it. Okay, next one, number 2. Angle addition postulate. Okay? Angle addition postulate is when we add angles together. Just like we add segments together, we could add angles, right? Remember measuring angles last week on the protractor? Yes? Okay, cool. So we have 2 angles up here. Let's say this angle PQS was 75 degrees. And let's say this one was 20 degrees. If PQS is 75 degrees and SQR is 20 degrees. How many degrees is PQR then?
95.
95. Do y'all get that? When we add angles together, it creates a new angle that's the sum of both of them. Okay? Okay, ones, back to you. Talk to your group really quick, 7 seconds. What is the angle addition postulate? Ready, set, go.
Really?
Okay? Last one, linear pair theorem. We talked about this already. What do we know about lines? How many degrees is it just a line if it's by itself? 180, right? So if I have this line right here, it's 180 degrees all the way around, right? Okay? But that's not the case. We are saying that angle 3 plus angle 4 is equal to how much? 180. It's supplementary, and because they share the same line. So it's a linear pair. Okay? We already know this. Whew! All those definitions. Man, that was boring. Okay, you need to know all the definitions. Why? Because you have to apply them. We're going to apply them. So here's the actual lesson today. All that was like, oh gosh.
That wasn't the lesson.
That wasn't the lesson. Okay? Let me show you why. Okay? We're going to talk about deductive reasoning. We'll get through this because I know period 2 got through it. You could do it, okay? I promise. We'll make it interesting. Ready? All dogs are yellow. Mr. Ink has a dog. Therefore what? Yellow. Okay, cool. So in math, you have to be able to prove yourself, okay? Listen to this story. Listen to this story. Ready? Ready? You were talking to a friend. You saw the Super Bowl. You know the Patriots won. But your friend was watching the Super Bowl with you, but left during the fourth quarter. And they're like, no, the Falcons win. I didn't see the game, but I know the Falcons win. They're way better. Okay? How would you prove to them that they're wrong? Okay? So, what happened in... Ready? Wait up, wait up, wait up. Tell them what... They don't believe you unless you describe it. So, what happened after the at the fourth quarter? Who scored 21 points? Okay, so fourth quarter, Patriots scored 21 points, and then at halftime, at the end of the fourth quarter, what happened to the score? They tied. That's the second thing. So the first thing that happened was the Falcons were winning. We knew that. Then they scored 28 points. Then they were tied. What happened in overtime? The Patriots scored. Therefore, who won? Patriots. Does that make sense? So you have to be able to prove to your friend what's going on, right? With rules and facts. Did we share facts just now? Yeah. Okay. Did we say, were one of our facts the Falcons suck? No, those we used facts, right? We didn't make opinions, right? Okay, eyes up here. Here we go. Hey kids, we're gonna get through this whether you're gonna stay after class or not. So I need you to help me. I'm trying to go as quick as possible. Now we're not writing the steps. Here we go. So we've done this before. I'll do number 1. Okay? So I'll just say it out loud to save time. To go from here to here, what did I do for this equation to go from here to here? What did I do to both sides?
Minus 4. No, wait. Minus 4. No, plus 4 on this side.
What did I do to both sides? Add 4. What did I just use? The addition property of equality. Remember doing this? Okay, good. So I just proved the first step, right? Patriots scored 28 points. That's what we just said. Okay, and then what did I do to both sides here? Good. What property did I use just now?
Addition property.
Oh, okay, cool. They're tied at halftime. Okay, and then what did I do to both sides here? You flip it. What property is that? It's one of the new ones. Coke and dollar. Coke and dollar.
No.
This one probably has.
No, it's
Think about your face.
Reflection property.
No. Symmetric property. Symmetric property, right? Okay. So we use all of the properties to get through or to describe what happened. Let's do number 2. Okay, we're gonna stay after class. Okay. Number 2. 15 seconds. Talk to your group. What properties are used right here on number 2? Ready, set, go.
So the minus 9 over
Ready? Okay, what happened on the first step? What property was used on the first step? Subtraction property of equality. Good. What happens on the next step? What property? Good. And what happened in the last step? Property. Okay, that's it. Okay? We've done this before. Now I'm going to go to the next one. You're going to be doing proofs in math. So it's giving us this picture right here. They're like, it says use a postulate or theorem to find the value of x, okay? So how would you figure out what x is? Well, I see a picture here. We have RT, and we have S in the middle, which means we have RS, and then we have ST, and we could figure this out. It gives us something. It says RT is equal to 5x minus 12. So I'm going to do this proof for you, and you could write it as I go. I need you to write with me, and I'll explain why. So RT is equal to 5x minus 12. This is the last thing we're doing, okay? Okay. Where did I get this from? It was given to us. So the reason that I'm putting this up on my paper is this was given to me, okay? Then I also know that isn't RT equal to this piece of the segment plus this one? Would you all agree with that? So RT is equal to RS plus ST. What postulate is that? Something addition postulate. Postulate 1, what is it? Segment addition postulate. Right? We know this is true, right? So we would write that down as our proof. Okay? Now, I'm looking at this and I'm saying, hey, look, if RT is equal to RS plus ST, couldn't I substitute the original RT with RS plus ST? So can I substitute it right here? You see how I substituted RT for RS plus ST here? And I'm bringing the original equation down is equal to 5x minus 12. What did I just do here? I just told you. Substitution property. Make sure you're writing this down as we go because you need this. Okay. What do we know about RS and ST? What's RS equal to? Well, let's look up here. What's RS equal to? Good. And what's ST equal to? Good. So then we would write that down. We say we know RS is equal to x plus 2 because that's given, and ST is equal to 3x minus 8. Okay? This was also given to us. So if that's the case, then we could say we could replace RS. You see RS, we could replace it with x plus 2. So we're replacing RS with x plus 2 right here. And then we're going to replace ST with 3x minus 8. And bring the rest of the problem down, 5x minus 12. Okay, y'all see how I just replaced this third line with this one down here? What's it called when we replace things? Or what property is that? Think of a hamburger. Right, we're substituting, right? Okay, and then we're going to combine like terms. We got 4x minus 6 is equal to 5x minus 12. This is called the combine. We're going to combine like terms. We learned that from before. Then I'm going to subtract 5x from both sides. And this is called subtraction property of equality. So I'm going quickly here. Do you all see the progression here? And then we're going to add 6 to both sides, so we got negative x is equal to negative 12. And that was the addition property of equality. out of time here, but you would write of equality, and then we're going to divide both sides by -1, so x is equal to positive 12, which is the division property of equality. Dang, that was a lot of work, right? Would you all agree with my answer that x is equal to 12? Yeah. Did you all see that we went through all the steps here? We proved each step with a rule or postulate or theorem that we know about. Does that make sense? We used facts. Did y'all hear that? Okay, so this is where we're going to. This is kind of hard. Would this be hard if you didn't know all these rules? Yeah, so you have to know all of the rules and definitions. Otherwise, you're going to not be good at this, okay?